I'm going to show here a number of solutions that were proposed to solve the problem of the hierarchy of the data. The first solution is to just analyze the data as if level 2 didn't exist. So in this case, we've got self-confidence in the x-axis and motivation in the y-axis. We've got the 8 observations of the 8 students, and we ignore that they belong to 4 different schools, and we just obtain a linear model, a regression line that with those 8 participants. Well, that is incorrect. It's not the right solution because we are violating the requirement of independence of the data that linear models have. It would have been nice to do this because in terms of the simplicity of the model, this is a very simple model. It has one intercept and one slope. Okay, so let's try with another solution. The solution number 2 is one that is done regularly in experimental designs, which is to average data at each instance of level 2. So in this case, we've got the yellow dots belong to the 2 students in school A, the orange ones in school B, the blue ones in school C, and the white ones in school D. So what we can do, instead of using these 8 observations, we average at each school. So we obtain the average, and now we've got only 4 observations. And with these 4 observations, we run. These 4 observations now are independent because they belong to different schools, and we can run a regression, and there is no problem whatsoever. Now, the problem of this, even though it's typically done in experimental designs, there is a huge loss of data. From the point of view of simplicity of the model, this is good. We've got one intercept and one slope. But again, we lost a lot of data. We had 8 observations and we analyzed the data with 4 observations. Solution 3 is to do one analysis per instance at level 2. So basically we do a regression model, or linear model, for each school. So this figure shows 4 regression lines, and each for each school. You can see that in the school C, the regression line is even negative. Now, this again, this solves the problem of independence of data. Now, this within each school, the data is independent because now we don't have the school would be the population in which that I'm referring to. It's not a group within that population. So we solve the problem of independence of data. But the problem is that, well, is this informative? Are we interested on the role of motivation, of the relationship between motivation and self-confidence in each school, or we are interested in the role of these two, the relationship between these 2 variables overall, not just in each school? So it may not be informative. Sometimes it's not even possible. Look at this case. We typically don't have this so small data set, but with 2 points but even with a few more points, it's very difficult to have a reliable model. So that is a problem. And then we've got too many parameters to estimate. So in this case, we've got 4 intercepts and 4 slopes. But consider that we may have 1,000 observations in 25 schools. Then we will have 25 intercepts and 25 slopes instead of 1 and 1 as in if we do the solution 1, which is to ignore the hierarchical structure of the data. So these are the problems that we have, and the solutions that have been used, which are none of them is satisfactory. So what's the solution multi-level modeling provides? Well, basically it makes an estimation of the regression line for each of the schools in this case, but this is not going to the parameters that are going to be used in the model. The parameters are, first, we obtain a sort of average of the intercepts of the linear model. So instead of having 4 intercepts, we are going to have 1 intercept, and that intercept is sort of an average of the 4 intercepts. And then we calculate the variability, so how much the 4 intercepts are far away from the mean intercept. And we do the same for the slope. We calculate an average slope, and then we have a variability. So we've got for each slope, for each school, how much they vary from the mean slope. And so instead of having as parameters each of the slopes of each school and each of the intercepts in the schools, we calculate either the standard deviation or the variance. So because we've got one mean slope or one mean intercept, and we have 4 slopes and 4 intercepts, and we calculate just as a normal variable, we calculate the standard deviation or the variance. So instead of having 8 parameters here, we only have 4, and this is the right choice, because we have we solve the problem of having too many parameters, because here we have 4 versus 8 in the model that produces a regression line per school. But imagine that we have, let's say, 1,000 observations in 50 schools. So in that case, we will have 50 intercepts and 50 slopes, so 100 parameters. But the number of parameters in multi-level modeling doesn't change. We still have 1 intercept, the variability of the intercept, and 1 slope and the variability of the slope. So we always have 4 parameters, even though we have many schools or many instances at level 2.